Hi everyone, welcome to the channel. In this video, I am going to show you how to apply earthquake load to a building using ETAB software. In this channel, actually all this earthquake loading is based on IS 1893 2016. So let's start. So first I am opening the ETAB software. One second. It takes time. Whatever I am using, it is only IS Indian Standard Unit, SI units. So new models. Here, here is the option for use built-in setting with SI matrix, India. Our steel design code is IS 800 and concrete design code is IS 456. According to your country or unit, you can change it. Means there is a lot of countries like Australia, Canada. You can choose any whatever you want, but I am using India here. Then uh, I'm just taking the random structure. So just grid, uh, number of grid in. Okay, you can modify the grid from here also. Just right click, add modifying grid, and this is for story data and this is for grid system data. So modify showing grid system. Here is spacing. I want 3 number of bays, so have a 4 meter length. So you can see according to your, if I'm changing the x direction, it is modifying here, and this is 3 3 3. I want only 2 bays, so I'm deleting 1 bay. So you can see here. Now story, modifying story data. I can add, just right click here, you can add the story as well as you can delete the story. So now I do not need to add or delete anything. So now my story grid is generated. Now second thing is go and define the materials. So add a new material, India. First I need concrete. Whatever structure I am making here, it is only concrete RC structure. So I am using M20 grade concrete. Okay. Now here you can see material type is concrete, isotropic. This is by default values of this all concrete properties, so no need to change anything here. Now this is material property data, no need to change here anything. Now nonlinear data is acceptance criteria for strain. It is performance point, IO level, CP level and LS level, and this is stereosis type. So for ESA no need to do this all things, so I am just ignoring this thing. And this is material damping. Material damping is a 0.5% for concrete, but for linear analysis no need to do anything here. So just this is time dependent properties, so I'm saying okay. Now my concrete is defined. Now I'm going again, add a new material. This time I need rebars, FE 500. Randomly I am taking this all things, okay, so no need to worry about it. This is a steel rebars properties. This is nonlinear properties. This is stress strain curve of the our steel, and this is damping. Okay. Now I define my materials. Again go to the define. This time section, frame section. First I have to delete this all material whatever defaulted or by default properties of the materials. I am deleting this all. Add new materials, concrete rectangle, beam, M25 grade. You have to choose whatever material you want here. Now I want beam 350. One second. Depth of beam is 450 and width of beam is 300. And this is stiffness modifier. This will actually in IS 16700 2017, they already defined whatever you want stiffness modifier in a structure. So I will show you this thing later, but now for beam, stiffness modifier for beam is 0.35, means 35% in both direction. So just so that's why in 2 axis and 3 axis you can see here 2 and 3, this is local axis for a cross section, not for a whole structure. So this is 35%. And here for actually if you want our structure, one more thing, for beam I have to select the design type as a beam. Okay, this is very important things. If you are showing okay it is column and you are selecting beam here, then our column behave like a beam, so it is very important. So remember this thing. Now I need my longitudinal bar as a 500 and our confinement is F415, and this is a cover I am selecting as a 50. And no need to select this thing because I need to design the model, not checking the model. If you want to check the model, then whatever you have steel already just put here, and after that if it is sufficient, then it will okay, otherwise it will not okay. So okay, now my beam is defined. Again, add new property, concrete section, rectangle. Now column and 20 grade, 350 by 350. For column it is stiffness modifier is 70%. And this is very important here. You can design types is okay column. This is longitudinal bar is 500 and confinement is 415. Confinement configuration is rectangular. Okay, confinement bar is tie. Okay, now here it is very important. This is I want design, not to check. Okay, so if you are clicking on the design, then no need to worry about this all things, because whatever you are selecting here in the design criteria, according to the load, it will show you how much reinforcement is required. But if you are clicking on the checked, then you have to fill this all things, and then according to your reinforcement input, you will get it, is it safe or not. So this time I am designing it. So okay, and then okay. Now I already defined my cross section properties, frame properties. Now slab section. So modifier, one second, add new property, slab 125, M25, thickness of slab is 125. One more thing, this is modeling type. Is it a membrane, is it thin shell, is it thick shell? I will tell you this all things later, but now just click the shell as a shell thin. Actually in shell thin, no, you are not considering the shear force carried by the slab. But if you consider the thick shell means it will carry your shear force also. But if you are clicking on the member section, if you choose the membrane section, then it will not carry any force. It will just it will translate all force to the beams. So this time I am taking shell thin, and this is stiffness modifier. So stiffness modifier for slab is 0.25. So okay, okay, and okay. Now I already defined our frame frame members as beam and column and slab also. Now go to draw, and you can see draw beam column, draw. This is quick draw or quick draw beam column, and there is already by default in the title bar you can see this is quick bar beam column. Click here and you have to select property type as a beam, and if you're clicking on the beam section you can see all beams are this beam are selected, but it is very useful property in setting is here by ETABs. This is one story and all story. If you are clicking again here you can see in the all story related to this all selected or assigned a one single property, so it is making easy things. So now my all beams are assigned. Now column, I change the property type. Now elevation, now you can see my columns are selected, but it is very lengthy to select each and every time, each and every section. So what I can do, I just select going to the edit, replicate, and this is my y direction. So in the y direction my beam length is 3 meter, means 3 meter 3 meter. So this is just 3 meter. How much you want? It is 2, means after selecting this it will replicate. Okay, so I have to select the columns what I want to replicate and apply. So you can see after this it will replicate and select it. Okay, now again go to the quick draw floors, plan top story, and in my property is slab 125. So I select here once again. Now you can see in everywhere slab is assigned, but I do not want to slab in the ground story in the foundation side, so I have to delete the slab. So just click on the advanced single story and plan, go to the base and okay. Now our base is selected and delete. So you can see this is very useful thing, one story or all story. Now my member already assigned. Now go to the assign again and joint and freestone. This is important because I want my foundation as a fixed support, so that's why in the bottom story, or you can say in the foundation side, I need to make the foundation fixed. So plan base, okay, select all, fixed support and apply. So you can see here, one second, you can see here all my joints are fixed here. Now okay, so I assign the joints. Now I have to assign the load pattern. I have to define the load pattern. So first is dead load. dead load. For dead load, self multiplier is always 1, means it is already calculate the dead load by itself. I do not need to assign dead load additionally. So that's why dead load multiplier is always 1, modified dead load. For live load, I do not know how much live load I have to assign or not. So live load should be 0 because I will apply live load by myself. Now super dead load. Super dead load is a kind of dead load, but it is considering different dead load, means like wall load, whatever you want to assign in a structure, but you can't model in this structure, so it will calculate by SDL. Now dead load, live load. Now floor load. 1 second. Floor load, it is in the part of super dead load. Add. Now earthquake load. ESA X. Load type is seismic. Auto lateral load, you can see here according to Indian code IS 1893 2016. Add. And same for Y and add. But remember one thing, actually here you have to modify the properties, means after going to the ESA, go to the modify lateral load, and you can see here for ESA you have to consider only X direction. This is plus eccentricity, means actually whatever eccentricity, or you can see say minimum eccentricity after at the time of earthquake is 0.5%. So you have to think about it, means you can always remember this is important. You have to uh, apply, you have to calculate the eccentricity and then put the value here, and at which seismic zone you want our structure, means according to city there is a seismic zone, so according to city you have to select the seismic zone and its value, and soil type 1, 2 and 3. Soil 1 is for hard soil, medium soil 2, and third for soft soil. And this is importance factor. This is depend on the types of building. So I am assuming it is a normal structure, or so that's why 1. And this is important response section factor. If your thing if your structure is a moment resisting frame, a special moment resisting frame, that time it is 5, or otherwise it will 3. So okay, now same for Y, and this is okay, okay, and all are okay. 1 second. Okay, now I define my load pattern. Now uh, I am going to assign the loads on our structure. So assign frame load distributed. Simply I want to just suppose I want to make our structure in the periphery side. I want there is a wall, infill wall. So maybe in the infill wall the load is UDL. So just simply select the floor. See, this is super dead load in gravity direction. 1 second. This is super dead load gravity direction. I want this is nearly 13%. I am assuming, sorry, 10 kilonewton per meter. This is I am assuming. You have to calculate according to density of the wall and then put the value here. Okay, and this is replacing existing load or add a existing load. I will tell you this thing later. And apply. So you can see here it is showing the dead load, super dead load or infill wall load on the structure. Now again I need to assign the load on the slab as a live load. So live load I am assuming it is 3 on whole structure. So one second. So I am selecting the floors, assign. Actually what I did mistake here. For frame load I am assigning the slab. It is in this assign, go to assign, shell load, uniform load, and here you can see the live load is 3 kN per meter. So you can see 3 kN load is applying in whole structure. Again I am selecting all the floors, and this time I need floor finishing. So if I am as a 1 kilonewton per meter square, suppose if this is option coming here in the picture, if I am applying 1 kilonewton load and replacing existing load, then it will replace 3 kilonewton. So I have to remember option add to existing load means it is already here. Live load is 3 kilonewton, is already here. Now I need 1 kilonewton per meter square also in my floor. So it is very important. Add. So you can see, just click on the slab and right click and go to the load. Now you can see our floor load and live load both are here. You can see in any slab, you can see it is blinking, means this particular area, particular member you are selected. You can see same for beam also. Go to the load and you can see 10 kN per meter square. Now I apply the load on the structure. Now I have to go to diaphragm and define the diaphragm. Add a new diaphragm. Always remember, it is very important that if you are selecting rigid diaphragm, actually most of the structure we are assuming our slab is behave as a rigid diaphragm. Actually we want to make slab as a rigid diaphragm, but if in some cases if there is an opening or something is there in the slab, then you have to select the same rigid diaphragm according to our IS 1893 clauses or any other code clauses. So I am defining different diaphragm for different slab, different floors. Okay, 1 2 3 4, we have 4 floors, 4 diaphragm is assigned, define. Now go to the assign and joints and diaphragm. Here you can see diaphragm 1, select one story, select the story. One second. Apply the diaphragm. Again go down, select, apply second diaphragm. Go down, select, apply third diaphragm. Down, select, apply fourth diaphragm. you can see actually whatever performance is done here, it will show only in particular selected window. So that's why it's not showing here. All is processing happening here. Okay, you can see D1, D2, D3, D4. All diaphragm is assigned. Now one more thing, how actually I want my joint as a fully rigid joint. So I am selecting all the structure and going to assign frame and length offset. So you can see here rigid zone factor. I want my rigid zone factor as a 1 and define length is 0 0 means I want my joint rigid only, not any member. So apply. Now my joint is rigid. Now I define diaphragm, PL levels, no need here. Now I need function. Uh, Before this, I need to define the mass source. Mass source is very important thing. I will show actually in our IS 1893. 1 second, I will show you. This is IS 1893. So in IS 1893, this is load calculation, lateral load calculation formula. Here W is there. W is seismic weight. So seismic weight is same as a mass source here. Means how much mass of the structure is participating for earthquake. So add a new mass source. Mass source. We have to specify the load pattern, means what kind of mass source in given in the IS 1893. So this is element self mass, no need to consider this thing if you are considering this. Okay, so how much your load is participating, dead load, full dead load will participate in a structure. Okay, then add super dead load. If earthquake will come, then definitely our super dead load means our retaining wall, nothing will skip. Okay, now so it will 1 also. But live load in IS 1893, it is showing you 1 second. If so, here you can see this table number 10. What is it telling? If our live load is more than 3 kilonewton per meter square, then 50% mass of the structure is mass of the live load, 50% live load is participating for earthquake. If it is less than 3 kilonewton per meter square or up to 3 and including 3, then 25%. So that's why here for live load I am taking 25% only. This is getting it, no? For live dead load it is fully participating, super dead load is fully participating, but live load is 25% is only participating. Why? If it is more, live load is more than 5 kilonewton, 3 kilonewton, then okay, I will take 0.5, but in this case it is 25% only. So just okay. Now my mass source is also defined. Now my load pattern, you can see here load pattern is defined. Now my structure is ready to run. I do not leave anything here. You can see response function is not necessary for ESA. So first I am telling you how to use ESA in our structure software. Then after that I will show you RSA, means only I am doing static analysis here. So just run. I'm saving this as a ESA. new IT. So now analysis is running here. Now my analysis is done. I'm going to display show tables, structure output, and OK. So you can see here it is showing the ESA and RSA result. So ESA it is 172. If you are calculating the ESA manually, so it will show you that you will get this result. I will tell you these things later how to do ESA manually. So in software it's showing the 174 kilonewton total base shear. So this is ESA. I'm running it. Now again unlock the model. I want to show you one more important things. Actually in my structure there is an infill wall. There is an infill wall, but I am leaving infill wall here because modeling the infill wall it is difficult. So that's why I leave infill wall here. But because of infill wall, our structure time period will change or our structure performance will change. So what I have to do, I have to calculate the 1 second in our 1893 IS 1893 there is a uh, calculation of time period formula is given in in 7.6. So you can see here for bare moment resisting frame there is a formula for RC building, steel building and composite building. Same for structure wall also. But my structure is not a bare frame. In the modeling it is bare frame, but in the actual practice it is infill bolt with infill bolt. So what I have to take, I will calculate according to this formula and then I put the time period there and then what is the change in the base shear I have to see. So I am calculating the time period according to this formula 0.009 h under root d. So I am coming in the structure. In x direction my d is total d means one span is 4 meter, sorry, 4 meter, 4 meter, 4 meter, total is 12 meter. So 12, sorry, so 1 second, square root of 12 inverse multiply 0.0 1 second 0.09 into h is 1 2 3 4, so 3 into 4 is 12, so it is 0.311. So define load pattern for x direction, go to the modify and you can see here time period user defined it is 0.311. Okay, now it is okay. Now same process I have to do for y direction. So again calculate the 0.09 multiply 12. Now this time our d is just 6, divide by 6, root, answer 0.44, 0.44. Okay, okay, and run. Now go to display, show tables, structure output, and now you can see our load is changes, means our structure forces depend on the time period also. So this is very important thing. So now okay, so this is all about our ESA. You can see the mode shapes also. Just go to the deform shape, select the ESA and apply, start animation. Stop animation. For Y direction, stop. So this is just a deform shape. Okay.